All right, so if you drive a Chevrolet or a GM vehicle, there's a good chance you've seen a message that can kind of make your heart skip a beat. Battery saver active. It just pops up right on your dash, and all of a sudden, your mind is racing. Is my car about to die? Well, we're going to demystify that message and show you exactly what to do about it. Seeing this warning light is, understandably concerning. It feels like a huge problem is brewing. But here's the good news. A lot of the time, it's not nearly as serious as it seems. We're going to break down exactly what your car is trying to tell you and how you can find the real issue with just one simple test. So what even is battery saver active? Honestly, the best way to think of it is like your car's own low power mode, just like the one on your smartphone. When your car's computer even suspects there might be a charging problem, it kicks this on as a safety net. It starts shutting down the non-essentials. Your radio, the AC, heated seats, to save every last drop of power. Its number one goal is just to keep that engine running long enough for you to get to a safe spot. So it's a precaution, not a full-blown disaster. But, knowing it's a low power mode is only half the battle. The real question is, why did it turn on in the first place? Is the charging system actually failing, or does the car just think it's failing? Let's dive in and see how one super straightforward test can give you a definite answer. And what's really great about this is you don't need to be a master mechanic or have some garage packed with expensive gear. Nope, all you need is a basic multimeter. Seriously, a simple $10 or $20 tool is all it takes to play detective with your car's electrical system. The whole process is incredibly simple. We're just talking about a 3-step voltage test. First things first, you're going to set your multimeter to DC voltage. Second, with the engine totally off, test the voltage right across the battery terminals. And third, you're going to do that exact same test again, but this time with the engine running. That's it. Those two little numbers are going to tell you everything you need to know. Okay, so for that first reading with the engine off, what we're looking for is a number of at least 12.4 volts. A healthy, happy car battery usually sits somewhere between 12.4 and 12.7. If your reading is dipping below that, it could be a sign that your battery is getting weak and just isn't holding a charge like it used to. But this next number, this is the really important one. With the engine running, your alternator should be hard at work, actively charging that battery. For that to be happening the right way, you need to see a voltage reading above 13.5 volts. Usually it's going to be somewhere between 13.5 and 14.5. This single number is our key. It tells us flat out whether the charging system is actually doing its job. And this brings us to a fork in the road. That one voltage reading you just took is the key to this whole puzzle. It's going to send us down one of two very different diagnostic paths, and it'll tell us whether we have a real mechanical problem on our hands or maybe just a faulty messenger. So here are the two possibilities laid out plain and simple. If your multimeter showed a low reading, we're talking anything below 13.5 volts while that engine is running, that means the charging system has a real physical problem. But if you got a good reading, anything above 13.5 volts, it means your charging system is working just fine, and your car just thinks there's a problem. Okay, let's explore that first path. Let's say you got a low voltage reading. If your test came back under 13.5 volts, it means your car's warning system was right on the money, and something in that charging circuit is genuinely failing.
A low reading confirms it. This is not a false alarm. Power isn't being generated and sent to the battery the way it should be. So what are the most common things that could be causing this? Let's look at the likely culprits.
The list of suspects, well, it starts with the most obvious one, a faulty alternator. It could also be a worn-out or even broken serpentine belt that's supposed to be spinning that alternator. Sometimes it's as simple as some corrosion on the battery terminals or a loose cable connection that's interrupting the flow. Or, hey, it could even be a weak battery that just can't take a charge anymore, or maybe a blown fuse somewhere in the system.
But what if your multimeter gave you a good, strong reading? Way above 13.5 volts. This brings us to our second path, the false alarm. And this is an extremely common situation where your car is throwing a warning, but all of the main parts are actually perfectly healthy. So yeah, if your voltage is good, you can breathe a huge sigh of relief. Your alternator is working, your belt is spinning, your battery is getting charged. The real question then becomes, why on earth is the car sending out a panic signal when everything seems totally fine? The answer in a huge number of these cases comes down to one tiny component, the battery current sensor. It's this small device, usually clamped right onto the negative battery cable, that's supposed to monitor the flow of electricity.
When this little sensor fails, it starts sending garbage data to the car's computer, which triggers that false alarm. It's basically a faulty messenger. And believe me, it is a known, super common issue on these vehicles. And here's the best part. After all that worry, all that stress, the fix for this very common problem is often a part that costs around $15. Just knowing how to do that simple voltage test can save you from replacing an expensive alternator you didn't even need, all for the cost of a $15 sensor. So let's bring this all together. Let's boil it down to a simple action plan. We've gone from a confusing warning light to a really clear diagnostic process. Let's just recap the key steps so you know exactly what to do next time this pops up. It really all comes down to this 4-step plan. 1. You see that battery saver active message. First step, don't panic. Just remember it's low power mode. 2. Grab a multimeter and do that engine on voltage test. 3. If the reading is LOW, under 13.5 volts, you're going to inspect the physical parts, the alternator, the belt, the connections. And step 4, if the reading is good, your number one suspect is that little battery current sensor. It all kind of leaves you with one final thought, doesn't it? In an age of these incredibly complex cars, sometimes the car itself is working perfectly fine, but it's just being misled by a single, simple sensor. So the next time a warning light comes on, it's worth asking yourself, is the car really broken, or is it just getting bad information?